Let's see another examples in sketching quadratic function. Example 2, we have the function fx equals to negative 2x squared minus 4x plus 6, where this equation is written in general form. So now, what we do here according to the techniques is that first, I would like to convert this one into the form that I want as stated below, fx equals to a bracket x plus h square plus k, by using the technique completing the square. So by completing the square, I will have the result as follow. In here, I doesn't go the details on how to do completing the square. You may refer to reference book or some other videos online to learn about this thing here. So with this form that I obtain after I perform completing the square, we can see that I have a as compared to the equation below equals to negative 2. The h is positive 1, the k is 8. And step 1, the type of functions already done. Next, we go on with step 2, we identify the shape of the graph. So based on these equations here, the functions that we have here, it's very obvious that we can see that for the x square terms, it's supposed to be x square term, for the x square terms, it's very obvious that the coefficient is negative 2, which is happen to be less than 0, or we can just say a negative coefficient of x squared. So we have a set face graph, and with this set face graph here, then we go for the next step to identify the important point, where the important point here is referred to the maximum point in this case here. So for the maximum point, how we happen to get the answer is that by referring to the functions after you perform completing the square, which is this one here, we notice that for the bracket terms here, x plus 1, when the time I have x plus 1 equals to 0, I have x equals to negative 1, and this corresponds to the x coordinates of the maximum point. Then the value of plus 8 here will corresponding to the y coordinates of the maximum point, and as a result now, I have my maximum point with the coordinate minus 1, 8. So there goes the step 3 is done. Identify the special point. And once again, by right reach up to here, we can happens to find out what is the domain and range graphically, although the graph is not complete yet, where we can see that from the graph here, by the time I expand the graph, it can go infinitely to left, to the right, and it gives us the domain equals to infinity, because it goes infinitely to the left, infinitely to the right. And whereas for the range, we can see that it can go as high as this maximum point here, where the corresponding y value is 8, and it can go as low as negative infinity. So therefore, I will have negative infinity until 8 close bracket for the range, if I want to determine the domain and range by graphical methods. Next, continue with our step 4. So step 4, we're going to make use of the maximum point to do a rough sketch to identify whether the x and y intercept exists or not. So based on this diagram here, when the time I do the rough sketch, I can identify that I do have a y-intercept, I do have x-intercept. So therefore, both of the x and y-intercept exist, so calculations need to be done to verify their locations. And what we have here for y-intercept, when x equals to 0, we find out fx equals to 6. Therefore, the y-intercept is equals to 6. Whereas for x-intercept, we just solve using calculator. We find out that fx equals to 0, x equals to minus 3 and 1. So therefore, x-intercept is negative 3 and 1. And as a result now, we have complete all the important information we need from the graph. And now we can go for the last step 5, sketch the graph. So in the graph sketching here, once again, we check. We should label the x and y axis, label the origins, label the graph itself. The name of the function is f, so we label as f. The x and y intercept, so the y intercept, the x intercept, And at last, our special point, the maximum point. And that goes how we sketch for these quadratic functions here.